Well, good morning. We are here for another episode of Voices of Video. And as always, we are bringing you the foremost experts and I would even say interesting people who are doing really fun and cool things in videos. So this week, we are not going to disappoint you, I promise. And with that, I want to welcome Tsahi. Thank you for joining us. It's great to have you here. Yeah. So let's just jump right in to this conversation. But first of all, tell us who you are and how it is that you began to work in WebRTC.
Okay, so Tsahi Levent-Levi, Blog Geek Me for those who don't know, and also Senior Director of Product Management at Cyara. So I guess I started doing voice and video over IP years ago, from the age of 21. That was 25, 26 years ago. Been doing that as a developer, then project manager, product manager, and then CTO. I was CTO in one of the business units at Radvision back in the day. And then WebRTC came out. And when it came out, I looked at it. That was 2011. I looked at it and I said, well, something is going to change. I went back and said, we need to invest in this. I gave 4 different angles they wanted to invest in. One of them was WebRTC, give him half a year a person, and we'll decide what we want to do with it. They said no budget. And then they said, tell us what we're going to do next year so we can tell you what the budget, so we can use the budget. And I said, well, that's not how you build the future as a CTO. And I left. When I left, I opened Blog Geek Me as a website just to write the things that I wanted to write about. And for one reason or another, it became the place for people to read about WebRTC unintentionally. And that's the case even today. A few years later, I co-founded testRTC with 2 other people, a company that does WebRTC monitoring and testing. The company was acquired by Spearline in 2021. And then Spearline was acquired by Cyara in 2023, which is where I am now with testing and monitoring. And other than that, I've got my courses on WebRTC and a bit of consulting around WebRTC. So that's where I come from to this specific space.
Yeah, it's great. I mean, you've got, I really like, I've heard you tell the story before, when Google first introduced WebRTC as a protocol. And we're going to talk, by the way, we're going to jump right in here to really what WebRTC is, because I don't think everybody on the surface, all of our listeners are saying, well, of course I know what WebRTC is, but, it's a protocol. It's not actually an application, even though it gets talked about a lot. But yeah, I've heard you tell the story that in 2011, you read about it, you learned about it, and you said the world's going to change in terms of video, and it certainly has. So why don't we start there? Can you tell us? Go ahead and assume that maybe not everybody is an expert in understanding the WebRTC protocol and what the components are.
Okay, so let's start from the beginning, okay? We actually need to stop because it's Israel and there is a siren now.
Oh,
okay.
No.
So,
okay.
Yes. So if you want, we can continue about 2-3 minutes, but that's like...
Yeah. Well, you need to, you take care of yourself.
I'm in the right room, but we need to close here and stuff.
Yeah. No, you take care of yourself. Okay. Well, this is live. And so, this is live, and we here on Voices of Video absolutely stand with Israel. So Tsahi is joining us from Israel. And so we want to take this very serious. So I think while we're waiting for Tsahi to rejoin us, I might make a few comments. I'm actually joining, for those that see me on video, that my background's a little bit different, and even blurred. You can probably tell I'm in a hotel room. So So yeah, I am here in San Francisco where Demuxt just wrapped up. And if any of you were at Demuxt and we didn't get to, to meet or shake hands or get introduced, then apologies, because we would love to meet all of you. But what an amazing conference! And if Demuxt has been on your short list or on your list of must attend conferences, I really can't recommend it highly enough. It's 2 days of very interesting talks. It is an engineering conference. It is for engineers, and it's wonderful time of networking. There's, like I said, a lot of really great conversations, but some really, really interesting themes that are coming out, both at Demuxt and other venues at the moment. And it actually plays into our conversation right now. There's one very common theme, and that is that anybody who isn't taking a very, very hard look or a sharp pencil to your operational cost, well, it's coming. Get ready. You might as well start now. And I think everybody's already well on the way. And then there is this whole move to live workflows, and of course ultra low latency plays into this, and obviously that's where WebRTC comes into play here. But this shift of live and then reducing costs. Hey, Tsahi. All right.
Hello.
Good. Okay.
Yes, that's live here. Word.
Yeah, this is live. I felt I felt like a news reporter. I'm like, well, let's see. So let's talk about the Muxt and fill in there.
Yeah.
So anyway, good. Welcome back.
Yeah, and we just started. So WebRTC,
yeah,
right?
So it's perfect. WebRTC.
Okay. So when you look at WebRTC, the first thing is that it's two separate things, by the way. It's not one. The first one is there's the protocol stack, which is a standard specification of what is WebRTC. People are getting out of the room now. And the second thing is that it's actually the implementation of Google itself of that protocol stack. And that implementation today is called libWebRTC, but it's just WebRTC. And this is what is currently implemented in all browsers. So if you use Chrome or Firefox or Edge or Safari, they all use the same implementation with different wrappers around that. But at the end of the day, this is the main implementation. There are others, but this is the main one. From the perspective of what WebRTC is designed to do, okay, from my point of view, and I come from video conferencing, so WebRTC is a kind of a media engine. Okay, we had media engine before. You have a video conferencing solution, means I have media engine there somewhere that needs to handle the voice and video. That media engine is built and designed for real-time, live stuff. I don't care about stuff that goes over VOD, things that are streamed, and we can send it to you, and if you get it a minute from now, that's fine. We're not talking about these things. It's live. I need it below 1 second or things are going to be bad. Okay? And the main difference between that media engine and everything else that came before it is that it has a standardized API. Okay? It's very important because up until then, what you had is different voice over IP protocols where someone needed to go think about what the API surface need to be and then implement it and whatever. WebRTC came and said, well, you know what? There is an API. That API is JavaScript. We're going to plug it into the browser, and this is how developers are going to use it. It's not this how developers need to implement WebRTC. It's how developers need to use WebRTC when they run inside the browser. These are like the capabilities that we're giving them. So first of all, it means that you don't have access to everything. Like, yes, you get packets over the network. Yes, they are received over UDP. No, as an application in the browser, you don't have access to them. If you have a native application, yes, but not in the browser. Why? Because nobody gave you that kind of an API surface. And if you have problems with that, go to the W3C and explain why you need it and, go through that motion of that process. And that mindset changed a lot of things because now what happens is you don't need to learn voice over IP in order to build a voice over IP application. You just need to be a developer and a web developer. And there are a bunch of them, a lot more than voice over IP developers, and they're building a lot of different things. And some of the things that they are building are not even video conferencing. They're just streaming services or totally different other things that nobody thought about before giving them such an API. And that, for me, is what makes it so magical and what gives it all of the power that it has today.
Interesting. So let's talk about somebody who wants to implement, let's walk through the process of building with WebRTC. Thank you for that introduction. So I'm sure in our audience, we have some folks who are working in video conferencing. So I don't want to dismiss anyone who is, but mostly, our audience would be building, let's say direct to consumer type applications, live streaming, or, maybe working in a very large social network where you're trying to, give your users ability to communicate, et cetera. So how would you begin approaching, building or implementing WebRTC into your solution?
I would start by using a third party so I don't need to learn WebRTC too much because it's too much of a hassle. That's the main thing. But really, so first of all, you need to decide where to use it and why. Let's say that I want to build the next Netflix. Okay, I wouldn't touch WebRTC with a long stick. Now, why is that? Because all of the content on Netflix was pre-recorded. Okay, and if I'm going to play it back, I don't care if you wait 5 seconds before your movie begins. I just don't care. It's fine. You won't care either. And if you care, then we can optimize it to 2 seconds and everyone will be happy. But there is no need to me to go down to 0. And now, if you go down to 0, you start losing quality. Okay? And WebRTC is about compromises. What does it mean? I'm using UDP and not TCP on the network because I don't need retransmissions. Retransmissions are bad in WebRTC. Why? If I'm sending you video and you don't get it, and then I need to retransmit it, once you will get it again, it might be too late to use it. So there are times and instances where we use retransmissions in WebRTC for specific things, but they're not for the things that you use them in streaming usually. There is no buffering in WebRTC in the sense that you see in streaming videos. Okay, so when you say I want live, and I care more about the fact that this will be live than I care about the quality of what I'm receiving. Let's say I'm betting on something in sports, then live is more important for me than adding latency, because if I add latency, it means that someone has an edge on me when he's betting. He knows things before. It's like, this latency of 2 seconds becomes important, or 5 seconds. I want to hear the goal along with all of my neighbors, not after them. Okay. I want to do this session with you, Mark, and then want to stream that to someone else. So at least the both of us need to be in a conversation that is live. So the first thing to ask yourself is, where exactly are you going to place WebRTC? Because there are different places to plug them in. So the first thing is, well, the viewers. Do they need it live? Yes or no? If they don't use WebRTC. If they do, okay, that's, we might. That's a good consideration of using WebRTC. Let's go to the inverse, the broadcasters. Should they be on WebRTC? Well, maybe. If they're doing this kind of conversation, they should be, at least between themselves. But then someone needs to go mix that and record that, and then it goes elsewhere.
Yeah, that's right.
Or let's say, you know what, I want to have someone join from a browser. I don't want him to need to install OBS. And I don't need him to install any other application. I just want him to open URL in his browser and magically he's there. Okay, and he can broadcast from the browser, from anywhere. The only way to actually do that today is WebRTC. Okay, so when I start looking at a solution, I would look at each and every component that requires video, and I would start asking myself things like, what's the latency? What is being used? Does it need to run in a browser, or can I use something else?
Mm-hmm.
Would using a browser for the user with a camera or microphone be useful for me?
Mm-hmm.
Is that beneficial? Does it give me an edge? And again, if the answer is yes, I'll go do that and use WebRTC.
Mm-hmm.
Okay. Usually, I would use a third party, either commercial or open source. There are many of them out there.
Yeah.
Self-development is nice, but you still need to start somewhere. Nobody starts by using WebRTC directly, not in this,
Yeah. Yeah.
not in these domains. And we need to
When you
remember
say third party, you're talking about like someone who's developed an SDK that is supported, that I can license, and
so I
they'll
guess
help me.
there
Or
are
what do you
like
mean by that?
there are three different alternatives. The first one is I am going to go and use a CPaaS vendor, communication platform as a service. I'm going to use
Yeah.
Max, have
Mm-hmm.
WebRTC and streaming. I can use Twilio to do the video, Vonage Daily, and Dolby, many other companies.
Yeah.
What they do is they give me a managed service that I can use, and that includes WebRTC, and I can just go and embed that into my application, the whole experience around that. And some of them are, their main focus is going to be streaming. Dolby has a solution for that. Daily goes to, I think, up to 10,000 or 100,000 viewers. And then you have Cloudflare that has their own solution with WebRTC.
Cloudflare. Okay. Yeah.
Yep,
There's
they
Live
started.
Switch, they
Yes,
have a
there's a lot
solution.
of them.
Yeah.
CPaaS vendors. The other one is, well, I'm going to go with the streaming vendors that have WebRTC solutions, and I'm going to use them because, well, I know how to use them. There you'll find Red 5 Pro, Woza, Ant Media, Nanocosmos, these vendors, where what they give you is the traditional or classic solutions for streaming that also have WebRTC support. So they know how to mix the two. And the third alternative is to go it alone. I'm going to develop it, and I'm going to use an open source platform. I'm going to use Janus or MediaSoup for that. And I'll build it from scratch, or I'll use Python and different types of usually media servers that would be able to get the traffic that I need and then forward it to wherever I need it. And then from that, I can mix and match the solution that I need around that. Okay, now if you go that route, you should really know WebRTC well.
Understand. You mentioned about quality. That quality in WebRTC is more challenged. Talk to us about the codecs that are supported, and then where those quality cliffs are. So why is it there's a quality issue?
So codecs for audio, you've got Opus mainly. There's G711, but everyone uses Opus. For video today, there's VP8, VP9, H.264, and AV1. All of them are available. The most common one is still going to be VP8 and H.264. You'll see a lot more VP9 these days, and you see the beginnings of AV1, especially on the decoding side in the browser. Encoders are hardware-based and different in nature. So everything is there, or most of the ones that are interesting. HEVC, there are noises from Apple of doing that in iOS. Okay. The main challenge there is going to be all the patents and royalties around that. So it seems that most companies in the domain of WebRTC are shying away from using HEVC, and they would use H.264 only if they must. That's usually how things happen with WebRTC today. The next part of your question was about quality and cliffs. So I guess if the network is great, and it never is, then the quality is going to be great, period. Okay? Either that, and you've got, or you've got issues with the CPU, and it's going to eat. The stupid things are about processing power that is needed. But mostly, you'll get issues from the network if the application is built correctly. Okay? Now, the challenge with the network is that you don't really own or control it in any way. I'm doing that here from my desktop with my machine sitting right next to the soft switch that I have. And that one is connected with Ethernet cable to this machine because I know the things that I need to use, and it's fiber to the home, and I pay dearly for that. Okay. That's not necessarily the case with all other people. This is me because that's my job. But mostly you won't find that. People will be on their Wi-Fi, located far from the access point, trying to do video calls while they drive in a car, on the highway, over cellular. Okay. And then the problem with these networks is that they have packet losses on them and latencies and jitter, on all of the nice things that we like to say about these networks. And what happens is this, again, if I throw a packet at you, if you catch it, you can decode it. But if you can't, what happens then? Okay. And if you go to the, let's call it the traditional streaming way, I'm throwing a packet at you, but I'm not throwing it directly. I'm putting it inside TCP or HTTPS, which is TCP. And TCP will make sure that if I send it to you, you're going to receive it. Because if you don't receive it, I'm going to retransmit it again and again and again until you either receive it or we both decide that the connection got broken. Okay. So life is going to be easy. The only thing that's going to happen is a bit of buffering. I'm going to be stuck on your screen, and then it's going to continue right where we stopped.
Yeah.
You can't do it with live. So I'm throwing packets at you. Okay. If you don't catch them because they didn't arrive, what happens then is that you need to do something about that, or we need to do something about it. So one thing that you can do is say, well, you know what? I missed that packet, but I'm going to assume that was an audio packet, and I'll take the previous one that I received and just reduce a bit the volume and, you know, hope for the best.
Yeah.
I'll skip that one. Or I didn't receive it on time, but I can wait 20 or 30 more milliseconds just to be sure. Or I can go and say, well, I didn't receive it. I know that it's an important packet, so I'm going to ask for that to be retransmitted.
Again, yeah.
Okay, so there are a lot of mechanisms in there that are going to be there to try and fix things. But you're fixing them while you know that they're broken, and it's like show must go on. I cannot just wait and pause everyone. Like we had this, you know, this chat between us, and then the siren came up here, and then a few minutes I was out, and that was the end of it, but you had to continue. Okay. Because this is live. So assume the same thing, but shrink it into like 50, 100 milliseconds of time. You cannot just, I cannot lose that audio because then whatever I'm saying, you won't understand, or my video won't pass the way it should be. So, and again, we have a challenge because the tools that we have must be tools that run in real time and cannot use retransmissions too much.
Interesting. You know, I think most of our listeners are probably familiar with scalable video codecs, but that's something that if you haven't worked in WebRTC is kind of a interesting concept. And the concept, you know, and so you can actually explain it. Why don't you explain it? Both for temporal and spatial, you know, scalability, because it is interesting how these bandwidth issues are handled, you know.
I think let's start with something simple. In streaming, what you usually do is use something called ABR, right? Adaptive bitrate, whatever, which means I'm going to receive the video on the server. I have time, so I'll take that video, you know, and then transcode it into 5, 8, whatever number of other streams that I want, each bit stream with different bit rates and qualities and capabilities. I'm going to segment it into 2 seconds or whatever, so someone can jump from one to the next. Now WebRTC doesn't work like that, not because it doesn't, but because WebRTC again is for video conferencing, and in video conferencing I don't have the time to do these 8 different bit rates. And also I don't need to, because this isn't going to 1 million people, it's going to the other 3 people. So I don't want to invest so much energy for so little benefit. So what happened in WebRTC is the first thing is, I don't know what the bitrate is going to be like, so I'm going to just dynamically decide on the call. While we're on this call using Zoom, which isn't WebRTC, but it's going to use the same kind of a mechanism, Zoom is going to check on each side of this call how much bitrate is available for me and for you. And then it's going to play with that throughout the call, going up or down based on the network and the CPU capabilities and everything else. Like just this movement of my camera change the amount of bits that needs to be sent over video, and that might change how bit rates are going to be allocated for the call. Okay. So the first thing that you have is a bandwidth estimator inside WebRTC that runs dynamically, changes the bit rate. That's the first thing. Now, the second thing, which means that you don't get perfect quality at all time, because I don't have the network for that. I might not have. Now, the second thing is that you can use scalable video, SVC. Okay, scalable video coding. It's not that common, by the way, today with WebRTC. It's there, but a lot don't use it. With scalable video coding, I can create a single encoded bit stream for video, and then layer it as if it's an onion. And each layer is going to add something to the video. I can say the first layer is a temporal layer with low resolution and 15 frames per second. In the second layer, I'm going to add more frames, so go to 30 frames per second. The next one is going to add resolution, and the last one is going to add like quality on that resolution anyway. Now I'm going to take that video that I create, that bit stream, send it to a server. Now the server can take that and peel that layers like an onion, and he can use how many layers he wants once he's sending it to other participants. So now I'm gaining something like ABR on the server without the server needing to transcode anything. So it can use less CPU, but serve a lot of different participants that have different capabilities, either because of network or CPU power. Now, this is nice, but what's actually really used in WebRTC in a lot of scenarios is something that is called simulcast. Okay, in simulcast, what I'm going to do is something else. I'm going to create 2 or 3 different videos of the same source, each one in different bit rates. So one of them is going to be at 100 kilobits per second, the next one is 500, and the third one with whatever is left. I'm sending all of these 3 to the server, and the server will decide which one to send to whom. Okay, it's like a poor man's SVC. Why do I do that? Why do I need that? SVC doesn't work well with hardware encoders and decoders, which means that everything needs to be done on the CPU. But simulcast is something that hardware decoders and encoders are fine with. So it makes it simpler for them to do that. And the extra bandwidth that I'm paying for is not that high in a lot of different use cases.
Interesting. Wow. There's there's a lot to WebRTC. You started a company doing tests and helping companies test. Talk to us about where you see the biggest pitfalls, or what are the common mistakes that people make in building their workflows or implementing, even if they're turning to a third party. What are some lessons learned that you can share?
I think the biggest one is not knowing or understanding WebRTC. And when you don't know it, you come with unrealistic expectations. Okay, I'll give an example. I had someone come to me and say, I want to build an application. That was before the pandemic even. I want to build an application that allows people to go travel the world. I want them to be able to go, see the Himalayas. So the actual person out there that goes into the Himalayas with his iPad, and the person at home can watch that from his comfort of his TV screen. It is so fine. The quality would be so great that it's better than Google Meet. And then you try and go to explain, well, there is no network in the Himalayas, and WebRTC was created by Google, which runs Google Meet. So how can you get a quality that is higher than that with something that is like, it doesn't match. Okay, so, and there are a lot of, this is an extreme, but there are a lot of these kind of unrealistic expectations.
Did they actually try and build it? or did they listen to
No,
you?
no. And my kids call me Shatterer of Dreams because I
Oh,
just do it. That's my job most of the time. The other one, most of the mistakes you'll see people do with turn and with bitrate calculations. They just don't understand that. Somehow turn servers or not traversal is black magic for a lot. And then when they try solving it, they solve it incorrectly. So usually you will start, I get people come to me and say, we have a problem. It doesn't work well. We're trying to optimize and we're checking if we can use VP9. And you go like, okay, but what is the problem? Like, where did you start from? And the story is, it's a sub story of, well, we have one user on desktop, the other on mobile. We did a native application and the quality isn't good. Okay. Why isn't it good? Is that the network, the CPU? Is it for a specific user in a specific location, scenario? You don't rush. It's like people rush to fix things before they understand what the problem really is. Because they heard somewhere that VP9 has better quality than VP8.
Yeah,
Hence,
right.
if I've got a quality problem with my video, it must be that.
It must be that I need a different codec.
Yes. Go explain them that up until a few years ago, MPEG-2 was still the dominant codec running their TV shows, and they were happy with the quality there. So it might not be the codec. It might be something else.
Yeah.
And just trying to, let's go back to basics. Let's see what the problem is, analyze that, and then decide on what the correct solution is.
Yeah.
So most of the time, it's just, it's looking at figuring out what the actual problem is, not what solution doesn't work for that person, just understanding the problem before charging towards a solution.
That is gold. The advice that you just gave, even, the VP9 example, like, I have a quality problem. So I need to implement a new codec because that's going to fix it. I need a better
AV1.
codec.
We're going to use AV1.
Yeah, AV1, exactly. Yeah. It's interesting. Obviously in NetInt, we have a hardware AV1 encoder. And so we're in the middle of a lot of AV1, migrations, or it's one of the, it's a major driver for us. But, we hear consistently that one of the very, very first tests that people do is they need to understand, like, wait a second, if I'm going to adopt AV1, I need to make sure that it's at least on par with VP9. No, it needs to be better than VP9 in terms of, bit rate efficiency and the quality metrics. But, and in some ways, that sounds like, well, that's obvious, right? But it's shocking how many evaluations or engineers start running down a path and they haven't even started with the kind of first principles, so.
Yes, and I need a lot of CPU power to decode AV1, especially if what I'm looking for is high quality at high bitrate. Now, if you look, for example, today in video conferencing, where do you use AV1? You use it in very low bit rates, and you're starting to see companies experimenting with that for screen sharing. Why low bit rates? Because it takes so much CPU that it's easy to do on low bit rates. And then you actually see a quality improvement. And why screen sharing? Because text looks better in AV1 encoding.
Yes. So while you stepped away there for a few minutes, I was sharing a little bit from Demuxed, since I just came back. Well, I'm still in San Francisco, and there was a presentation yesterday from a company that showed a video conferencing application. It was screen sharing, and they showed the difference between H.264. And it was a Wikipedia page, they showed, and it was like H.264 at like, so therefore your point, text, it was pretty much all text. There were some images, but, and I think it was around 900, maybe just slightly above 900 kilobits, H.264. And then they showed AV1 at like 170 kilobits, so,
yes, but that's,
And
It's
it was pretty remarkable, the difference.
yes, but
Not
it's
only
not a
in bit
match.
rate, but you know.
It's not, you
Well,
know,
why is it not a match? So
because
explain.
in a way, AV1 has the tools that make it better for text, period. Once you
Sure,
have that,
sure.
you know, there's no competition.
Yeah,
But the
yeah,
thing is, how the hell do I know beforehand that this is going to be the content that I'm going to encode? It's not as if I saw the movie at Netflix. I know that this is, you know,
yeah.
this is, I don't know, it's a drama, it's,
Mm-hmm.
you know, it's a drawing, something that is drawn. How do you call that?
You mean drama
Animated
or oh,
films, you know,
animated? Yeah, yeah,
animated
yeah,
movie, or is
yeah,
that like an
yeah,
action
yeah.
film? I
Synthetic.
don't
Yeah,
know that in
exactly.
advance. So, you know, I don't have the luxury of doing encoding 3 times in 3 different codecs and then deciding which
Yeah.
one is best. Or
Deciding which one. Yeah, yeah,
yes, Netflix can
yeah,
do that, and they are
yeah.
doing
Sure,
that to
sure,
reduce
sure.
bit rates. I can't. It's live.
Yeah, 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 yeah. That's
So
interesting.
you need to
Well,
get AV1 a lot more optimized
yeah.
in a lot of different broader use cases
Mm,
to be able to work with it everywhere at all times. It's not that you can't
mm-hmm,
use it today. Definitely you can, and in some use cases, it's the best thing ever.
mm-hmm,
But you need to
mm-hmm.
know what it is that you're doing if you're going to use that specific codec
Yeah,
and other
yeah,
codecs. It's like,
yeah. Understand. I want to pause here and just make a comment to the viewers. If you have questions, feel free to type it in the chat. Our wonderful producer, Anita, is monitoring the chat. And so Anita will make sure we see that. And if for some reason you've entered a question and we miss it, or we just don't address it, feel free to reach out and you know we'll get you some answers. So just make sure it's available. Tsahi, I want to, you mentioned turn servers. And it got me thinking that we haven't explained the path that a packet goes through using
yeah,
WebRTC from the moment that you know the photons hit my camera sensor and then they show
yeah,
up on your screen. Why don't you real quick explain you know,
it's
what does that
complicated.
look like? What is the traffic? Where are the toll booths?
I
Tell
think
us
it
where the toll
depends.
booths are.
I think the answer is it depends. Okay.
Okay.
WebRTC as a whole doesn't require anything. It works peer-to-peer from my machine to yours directly if we want to,
Mm-hmm.
and if it can.
Mm-hmm.
Okay. If it can't, we're going to use a turn server to relay that data. There are stun servers. There are a lot of things out there. Okay. But
Mm-hmm.
at the end of the day, there are two things that are going to decide how these media packets are flowing.
Mm-hmm.
The first one is the architecture of your application,
Mm-hmm.
and that you can control because you own that, and that's a very important piece. Like where do you have media servers?
Mm-hmm.
If you do, then well, you go through media servers, and that's out of scope of WebRTC, although these media servers communicate in WebRTC protocols. Okay.
Yeah.
But
Yeah.
they're not defined in the standard.
Yeah.
You're just
Yeah.
using them because it makes sense.
Yeah.
And they're very common. Usually most sessions today, I guess, would be between a user and the media server.
Mm-hmm.
And somewhere in between, especially in large calls or in streaming and stuff.
Mm-hmm.
So a lot of these sessions are going to be from a client to a server, and where the server is located is important. They want that to be as close as possible to the user.
Mm-hmm.
Okay. And then there are turn servers. Turn servers are there if I cannot reach the other side. The other side might be you, or it might be a media server. And if I can't reach you directly, I'm going to use a turn server.
Mm-hmm.
And the purpose of the turn server is to relay the media through the turn server to wherever it needs to go. Turn server can run media across UDP, TCP, or TLS. And it's kind of, in WebRTC, everything is kind of best effort. I'm going to try UDP. If it doesn't work, I'm going to try relay. If it doesn't relay over UDP, I'll try to relay over TCP. And if that doesn't work, I'll try to do that over TLS. Okay. And what's going to be used? Well, I don't know. Let's try and see what happens in this specific call, in this specific scenario.
Yeah.
Okay.
Got it. Got it. You mentioned media servers. So is there a trend towards media servers being used, and where and why? And also explain the functionality that can be in a media server within a WebRTC construct?
Okay, so first of all, it's not a trend. It's a reality of life. It's been from day one. And what do I mean? I see a lot of people that say that WebRTC isn't good, and we're going to improve and make WebRTC better.
Yeah.
We have some streaming companies doing that, and that's just
sure. Yeah,
it's so stupid.
you named some of them earlier when you were mentioning the
Yes,
platforms.
but
Anyway, we
sometimes
won't rename them.
what they say is we make WebRTC better because WebRTC is not good. It's peer-to-peer.
Yeah.
And the answer is no, it's not. You can do whatever you want with it. If you want, you can use a media server. It's great that you're doing that, but everyone else in the industry is doing that.
Yeah.
Okay.
Yeah.
I cannot send packets from my machine to 1 million machines. Impossible.
Exactly.
I can't.
Yeah.
So what am I going to do? I'm going to send the packets to a server, and that server is going to just go and route that packets to everyone because that's the role of that server.
Yeah.
Hence, in streaming, everything you're going to do is going to have media servers in there. In video conferencing for large groups, everything you're going to do is going to have media servers. If I want to record the session, most probably I want to record it and then play it back somewhere in the cloud. So I need to record it too, and on server that is online, media server or whatever, but I need a server that will host the media.
Yeah.
Okay. Sometimes I would say, well, I'm going to do it peer-to-peer because it's only the two of us. I don't care about recording, and I want to be cheap and not pay for the bandwidth over the servers.
Yeah.
That's fine.
Yeah.
But it's just one of the use cases where you can do this thing. It's not the major use case, it's one of them. So media servers are used everywhere. They're used to do group calls. They're used to do streaming to large amounts of people. They're used to do recording and transcriptions and a lot of other things that you need when you want to manage to host a meeting, the session, or whatever you want to call it.
Got it. Okay. Is it easy to build your own media server, or is this where you get into really wanting to use a third party?
A lot of the courses that I have, I do with Philip Henke. He's great. He's like the person with the most amount of bugs opened on Chrome on WebRTC ever. And we talked about that, about why would someone in his right mind after 2020 would go and write his own media server? And the only answer is because it's fun.
Okay.
There is no other reason to do that. There are multiple alternatives today that are quite good. Janus, Jitsi, MediaSoup, Pion, these are the main ones. Okay, they are all open source. You can download them, use them, change their code, modify them, optimize them, improve on them, whatever it is that you want. And they all have large communities around them. Each one is suitable for slightly different use cases and scenarios, and they use different coding languages and whatever. Nobody cares. You can just go and use that. So that's what I would do if I had to build something today from scratch. I wouldn't write code in C++ to start implementing WebRTC on a media server. I would go to one of the existing ones and just use that, and use the one that I'm most comfortable with and that the developers around me can use.
Got it. So we had a question come in. I'm going to ask it. So we will get to this. So let's see, VJ, if you're still on, we will get to it. But it's appropriate that we talk about scale of WebRTC because I was smiling at your comment about, commercial companies. WebRTC is bad, but we've made it better.
Scale.
And then the next comment is it doesn't scale, but we scale. No one else can scale.
Yes.
So why don't you talk to us again? Explain where the WebRTC doesn't scale comment comes from, and then what the solution is.
So I'll start with the solution. Have you ever used Google Meet? Does it scale?
I mean, I use it for 1-to-1 or 6 people or something. So I don't know.
It scales. It scales well. It doesn't. It scales like Zoom. Doesn't really matter. They have millions of users across the globe, and people are complaining, but they're complaining like everything else they complain about.
Sure. They complain about Zoom. They complain about Teams. We complain about it all. So.
Exactly. And Google Meet at the end of the day is pure WebRTC. So WebRTC scales. Now, you started by explaining at the beginning that, look, WebRTC is a protocol. do whatever you want with it. If you want it to scale, make it scale. If you don't want this to scale, don't invest the time in making it. That's it.
Yeah.
Okay. Where does that comment come from? You go into a room. There's a product manager, 3 marketing guys, and the 10 salespeople. And they want, give me something that I can tell the customer so he'll buy from us. What do we tell him?
Okay.
And then you get these stupid comments and things that companies say because they need to say something. It doesn't scale. We help you scale. You know, WebRTC was never tested. If you want to test it, come use testRTC. I can say that, but that would be stupid. Okay. Because WebRTC was tested, but if you're building your own application, you probably need to test your application. You
Your
can use
application.
us, you can use someone else, and you can do it manually. It's up to you to decide how, but you know, we're the only ones doing testing. Yes, sure.
Yeah.
Okay. So this is where it comes from. I don't think they don't do it on purpose.
No.
It's like just how companies think and work, where what they want to do is FUD, fear, uncertainty, and doubt, and that's fine.
Yeah. But is it so? Explain again. How does someone
let me say
from?
This. I'll ask a question. It's my turn.
Okay.
And does HLS scale?
Well, yes, because it's dependent upon the network. And it's dependent upon
you need to buy servers, and you need to buy transcoders, and you need to build the application properly, and you need to put CDNs in place, and then it scales.
Yeah,
HLS on its own is written on a piece of paper somewhere in IETF documentation or whatever. It doesn't scale. You can copy that HTML document and put it somewhere else, but someone needs to build the application that would scale. Okay, someone decided what type of servers to use, how to use transcoding, how big to make the chunks.
Yeah.
Someone did all that. Now, WebRTC isn't any different. WebRTC scales? No, it doesn't. But if I want to build an application with WebRTC, I need to build an application that would scale for my audience. Not more than that, not less than that. If I'm going to have, a target audience of 100 people in a single session, I'm going to run different types of servers. And if what I need to do, need to scale to millions in real time. It's going to have very different impact on how I'm going to architect my solution and what the media servers are going to look like on the network. Okay. I remember the first time I talked to a company that wanted to build a kind of a social networks-less messaging solution. What they said, we want to start by thinking about 100 million users and more. Okay. When you look at that kind of scale, you cannot use the same techniques that you use when you want to build signaling solutions for a dating application for the country of Israel that have 10 million people. And luckily, 100,000 are going to use that solution. It's a totally different problem with a totally different architectural solution. And I can say that because in testRTC, for example, each year we need to change the way we architect the solution. Why? Because we need to increase our scale considerably versus the previous year. And that means taking the next step or the next leap in how you need to do things and work to reach that kind of scale. So does WebRTC scale? Yes, it does, but you need to put an effort into that.
Yeah. Where is the cost in scaling? Because you also hear this comment. I've certainly heard it. Is it, hey, WebRTC is great, for people who maybe have a decent understanding. They say they agree with you. WebRTC is great. Hey, it's perfect. You have 50 participants, maybe you want 100 on a session, maybe you want a couple hundred, no problem. But you want like 1,000, you want 10,000, you want 50,000, it's too expensive.
It is
so
expensive.
I've heard that. So where is that cost?
So I think you can put it into 3 buckets. Okay. The first one is it is too expensive because we're still early in the game of WebRTC. Okay, costs will go down because today you pay for the investment of me doing that implementation that was never there in order to optimize it to run at such scales. And over time, we're going to reduce that price points. Like 20 years ago, using H.264 was ridiculously expensive. Today, it's cheap as hell compared to that. So give it time, 5, 10 more years, and the technology would be commonplace everywhere in terms of how you architecture. Now, all of the best practices are going to be in place. The second thing, I think, is remember when we talked about real time?
Yes.
So when I go from 10 seconds to 5, there is a cost associated with that, right? Now, if I'm going to spend the energy from going to 5 close to 0, the price goes up because I need to invest more energy into the tools and the solutions that I'm using to get to that level, okay, to that some second friction that I'm looking for. Now, when I look today, if you look today at video conferencing, it's really easy to do because you've got already 30 years or so of experience in doing that. It's still hard, but it's really easy compared to what?
Okay.
Compared to cloud gaming that also use WebRTC. Now,
Yeah,
why? Because in video conferencing, I can use 200 milliseconds and that's fine. I talk, you'll barge into what I'm saying and we'll manage. Okay. 200 milliseconds latency, it's fine. 300 also okay. 400 will still be okay. Now, if I'm on a game, cloud game, and that's 100 milliseconds, and that's a first-person shooter, I'm dead.
Yeah.
So then I need not 200 milliseconds, I need to just push it down to 50. And you see the energy that people invest in building cloud gaming and putting on the tools that are not really used when you do video conferencing. Okay, so the faster you want a solution to be, the lower the latency needs to be, the more energy you need to invest, the higher the price point is going to be. Just because of the realities of life. So if you're saying, well, it's too expensive. Yes, but you wanted it real time. You didn't want it 5 seconds later.
Yeah.
So either you pay for it or you don't.
Yeah, and this is an interesting observation. There's a very well-known industry analyst who, I think some in the industry are tired of hearing him say this, but it's true. And his observation is that as much as we all like to talk about ultra low latency, and he's obviously not referencing, like gaming or gambling type apps, or, there's clearly video applications where it needs to be, and you mentioned that earlier, if I'm gambling, like 2 seconds really matters or could really matter, but just in terms of like entertainment distribution, there just isn't a business case for it, and look, I'm, we're friends with everybody in the ecosystem. So, I know I'm going to get some hate mail from somebody, who's building a platform for ultra low latency sports or whatever. That's great. And, maybe we'll get there, but as you said, as you push those latencies down, the costs just go up so high. Now, and to the consumer, does it matter?
You will see that needed elsewhere though. And that would be on the production floor.
Yes.
Okay, that's where you start seeing solutions that are interesting because first of all, I want this discussion between us to be in real time and as quick as possible to actually go out there.
Of course, yeah.
And if we're talking about TV level production, maybe I want to do that remotely and have the producers sit somewhere else. And then using WebRTC to just go over the streams and decide which camera to take and how to merge the screens and whatever is something that you do with WebRTC while the stream goes to other participants, to the viewers over HLS or whatever. So it's not that there is no room for WebRTC, but it's probably not in the side of the viewers.
But as a distribution to mass viewers, there's not. Okay. Well, we're coming to a close. I promised I'd answer, or we'd ask this question. So the question was, broadly speaking, where do you see the industry going in terms of simulcast adoption versus SVC? This goes back to a few minutes ago when we were talking
I think
about that.
We're going to stay in the world of simulcast for at least 3 or 4 more years. At the very least, it's not going to change. I think that we might see more SVC when AV1 becomes commonplace.
Yes.
But only if AV1 SVC will be good enough and we'll have support for hardware encoders and decoders that make sense, which
Yeah.
means it is useful for real-time solutions and not just for streaming.
Yeah.
Otherwise, we'll keep on using simulcast.
Yeah. So working in the codec and encoding space, I can confirm what you just said about AV1. AV1 does have much more comprehensive tools, as that's why you're pointing out AV1 for SVC. And I do know, I can't comment just because I'm not really on top of some of the open source projects, but I do know of one commercial company that has an AV1 encoder that they've been focusing quite a lot, on the video conferencing use case and exploiting those SVC tools. So
what I said is slightly different, because what you need is for Intel, NVIDIA, Qualcomm, ARM, for these companies to have an AV1 encoder and decoder with SVC support. That is suitable for video conferencing. If you have that, then
the device,
SVC in WebRTC will become commonplace. Otherwise, it will be simulcast.
Yeah. Okay, good. Here's another question that came in. So can you use WebRTC to transport audio only?
I can also use it to transport video only. I can also use it to transport only data, no audio, no video.
Yeah, that's right. There's a data. Yeah, there's a data channel. Yeah, it's good. Okay. Yeah, and so for this person that asked the question, reach out. You can reach out directly to Tsahi or to us, and we'll put you in touch. If you want to chat more about that. Well, this was a wonderful conversation, and thank you so much for your time. Really appreciate it. I think we interrupted is it your son's birthday today that we interrupted?
Yes, my son's birthday, 2 sirens we had today. It was an interesting day today.
Interesting day. Well, you're safe, and we wish your son a happy birthday. And so, thank you again for sharing this amazing body of knowledge, that you've accumulated. So, thank you to the listeners. And certainly, whether you're watching live or on the replay, as they say, feel free to reach out to us or reach out directly to Tsahi. He's an amazing resource, and make sure you sign up for his newsletter, by the way. I love how short your emails are, by the way. No, I love it. It's like sometimes, I don't know, just 2 or 3 sentences, and then there's a link, and
then there are thousands of words in that link.
Oh yeah, exactly. But it's a very cool juxtaposition, So anyway, all right. Well, thank you again, and thank you to all the listeners. And until next time, keep encoding and streaming video using WebRTC.
Thanks for having me, Mark.
Yeah, you bet.